Do not breathe.
Don't touch.
Okay, so let's try again. So for me, I was always very much interested in MySQL and our like systems monitoring, observability, right? And I think in particular with MySQL. Why? Right? If you look at the users overall, right, there is a lot of complaint. MySQL slow, MySQL goes down, right, and so on and so forth, right? But typically, this is not due to the MySQL limitations. MySQL is a pretty high quality and powerful database, but it is often because folks are not using that correctly, right? And to understand why, how they're not using it correctly, and how to fix about that, that is where their monitoring observability is paramount. And I was always surprised what you would look at even some serious environments. So many people, especially like developers who don't really have a passion for database in particular, choose to fly blind. Just have a MySQL installed with no really insights and observability, right? And if it doesn't work, then go and scream a bloody murder. Okay. So what are we going to do here? I'll go talk a little bit about their performance optimization troubleshooting kind of. Okay. So anyway, so what can we do in terms of performance and troubleshooting? Right. So one thing I think is very interesting. What you often have like a different approaches, right? Especially in the larger teams, where it's not just or one team handling all the technical side, but it could be something like this, right? If you look from developer standpoint, especially somebody who is not expert in database, that's just want this database to work. Why is it always so stupid, complicated, whatever? You probably have heard all those words, right? Developers can use sometimes when database doesn't work well. Now, if you look at from the manager standpoint, it also often goes into, well, I don't want that to be too expensive. I think that especially becomes important in the cloud, right, when you can very easily scale by the credit card, go to the absolutely huge and expensive instance sizes as a way to solve the problem, right? And then you have somebody with a DBA title, right, wherever it is, who is kind of stuck in the middle and saying, hey, you know what, I want my developer happy, my manager happy, and then I also want to get some sleep sometimes, right? So that is kind of like a background. Now, if you look for a database from a very high level, from my point of view, right, well, it's a very simple service, really, right? You connect to a database and you run a bunch of different queries, and you just want few basic things to work, right? If again, from a very basic point of view, right? You want the queries to be executed with performance. You want to get correct results. If you don't, I have a fix for you. You can alter all your tables to have a black hole storage engine in MySQL. And then all the queries would be very fast. But maybe would not quite give you correct results, right? We also want not to impact the other applications, right? And I think that especially applies to somebody like a Java users, right? Because I know what Java people do when a database doesn't work well. Say, hey, you know what? Why don't I start 200 threads? And now things will become magically faster, right? But nobody else can get anything done at the database, right? That's often not a good idea, right? And again, as we talk about resources, also the important from a query point of view, because you often can scale up, but that is not very efficient and cost-effective scalability. Now, if you think about the queries, you can look at that also from a different point of view, right? From the database, we can capture queries either on application side, right, on the database side. We think what looking at us from a database, side often gives you a lot more insight, because that is where we have understanding what the hell is going on, right? With the queries, we have information about the plants and so on and so forth. Where if we capture query response time on the application side, on one side we see more insights, like we have a network round trip factor in, but then we don't have a lot of other details, right? Now, another thing what is very important as we look in this regard, to really understand what in the end the queries, number of queries and the kind of query that you're being sent, right? That's an application responsibility, right? And I think it's for me, what that means, very often I have to explain to developer what their problems cannot be solved on a database alone, right? In so many cases it goes into, hey guys, just fix your dumb database, right? We don't want to change our application a single bit. Well, that is not how things work, right? Another thing what we also like to look at is looking at the resources, the usage versus saturation, because if you have resources oversaturated, then that means everything becomes slow, right? Even your very kind of basic and benign queries, if you will, right? And these are the four resources which are most important to look at if you're looking at the database, right? Obviously, our CPU usage, the CPU memory, some storage and network, right? Typically, it all comes out to those hardware things. Okay, well, with that, I have kind of a couple of more slides, but I thought what would be better maybe to show some of the things connected to those concepts, which we can do with PMM, and you can also review more of the slides later. So now we're going to try to do another magic transitioning. Oh, look at that! It's actually even mirror display. Mouse? Did we kill mouse? No, we didn't kill mouse. Okay. Okay. So, some of you may see their interface of PMM, right? And I think the key feature of a PMM compared to a lot of, your own monitoring, which you may roll out with Grafana itself, is the query monitoring, right? And from my standpoint, I think that is a very important focus to look at that. Hey, if you can find what are the queries which are running, right, causing the load or slow queries, right, and deal with that, that is often a very good way to focus on. What we've done with PMM is also this design, what it looks at, not at a single node, but at the whole environment, right? Many of us run the shard applications, right, or something else, right, where we better look at the fleet of servers which may be running similar queries, right? So the in PMM concept, right, we spread that out as environment, right? You can have development environment, production environment, maybe something else, right? And then we can look at the different queries, where by default we sort them by the load, right? Which pretty much corresponds like a similar concept to a Linux load average, right? You can think about how many of the queries of this kind have been running in in average, right? In this case, I think what is very important in this is the trend, right? Because when you speak about the troubleshooting, we often would see the different pictures here, right? In certain cases, you can say, well, look at that, right? The system is overloaded. You have a load caused by this particular query, is spiking, right? That would be very different compared to saying, well, that query has a sustained common load. We also have additional information, right, about the number of queries, as well as query response time, right? And you can also look at the distribution of that response time, right? Like, for example, 99th percentile is often very helpful in addition to average. What you can see here is also the number of queries obviously does not always correlate, right, with what queries are causing load, right? In this case, some of the most frequent queries, but though they're simple, they don't create a lot of load on the system. Now, there is a lot of functionality here. Additionally, you can put various columns you may want to look at, right? You can may want to sort by, let's say, a query response time instead of a load, right? If you wanted to see, hey, this query gets the highest average response time, right? You can even look at the things like, well, what queries create temporary tables and so on and so forth, right? That's, maybe something what's is of interest interesting for you. So when we look at the queries and we have a fleet of servers, right? Often it becomes a question of where that query distribution come from, right? And that is where we have their filter. We can see what, for example, queries, what schemas, or what MySQL nodes getting their most of those queries, right? Which is, I think, a very valuable, especially in a sharded environment, right? Where we can say, hey guys, we have multiple shards, we kind of expect them to sort of perform the same, right? But what often happens in shard becomes unbalanced, right, for whatever reason, right? Or maybe you're getting their different query execution plans, on different shards because of some, MySQL optimizer budget. Well, by the way, if you have any questions, ask straight away. Let's keep that more interactive, right? Instead of trying to do it later. Okay, so in this case, let's say what we see there, MySQL 4, right, which gives us a lot of gets the most load, right, and we can zoom out to it, and we can see in this case what the queries would have refreshed, right, and we can now see only queries focused on this node, and then we have a number of schemas, right, where we can see, wow, now for some reason things should look really unbalanced, right, with that this schema have a 91% of a load, right? Then we can again zero out that, right, and see what this is the query, which looks kind of maybe benign enough, right? We can see the full query if we look here. For some reason is taking a lot load, right? In this case, we can slide the mouse always. Okay, gets a lot of load, right? Then you can zoom in this case and look at some specific information about this query to figure out, hey, what exactly is going wrong, right? When you think about the query, look at analyzing specific query, there are kind of two items which you can do, right? One is execution statistics, right? We can see what this query had so much in log time, so much rows examined, so many rows sent. One number I like very much look for the queries is how many rows have been examined per row sent, right? Because if you just have send in one row and examine a million, well, that is inefficient. Maybe that is just some group by query. We just have to crunch through a lot of data. Well, that also means maybe you need to build a summary table for that, right? Because MySQL is not very good in crunching many millions of rows, right? Well, Oracle believes you should be using HeatWave for that, rather than having a parallel query implemented, right? Okay. Well, anyway, but it's also maybe there are some missing indexes, right? Another very common reason why we scan a lot more rows than needed is missing indexes, right? And that is where we can look at the query explained, right? And in this case, we can find, well, yes, that's actually this query, even though it looks like it doing the primary key lookup, right? It's actually does a full table scan. Well, if we check the table, say its users, we can find what this table is missing primary key. Well, because I dropped it to show you, right? But in reality, right, you will be surprised how often something like that happens when people are running in a shared environment, let's say the process to add the index on 50,000 tables, right? And then it fails in the middle somewhere, right? Or one of the nodes, or it couldn't connect to one of the nodes, it was skipped, right? Wherever, right? And you see that schema drift, right, which often can cause the very migrations, right? So that is one thing. Now let's look at what we spoke on the other side, right? From, sorry guys, just as I leave it, so it gets me into, showing you some useless American news. Yeah, nothing interesting happen out there. It's not like people spraying shit on the streets like in Europe. Although that I think is in France, right? Okay, well, anyway, let's now talk about the also some of the resource usage, right? What I think can be quite interesting. What we have here is one we additionally to your various graphs, we also provide information from Percona Toolkit, right, which gathers a lot of valuable information about the systems, right, which was kind of selected as, I would say, helpful for a database workloads for many years. But now what we can see in this case, right, is what we look like. One, we talk about the CPU usage. One thing about also CPU usage, which is it can be interesting those days, is remember what MySQL executes a single query in a single thread, right? So often you have a bad job or something. You may be really bound by the single single CPU core, right, rather than by availability of the cores, right? That is why we also have a graph here where you can see the max core usage, right? If you would have something like 1 core pegs, you would see here, as well as their normalized CPU load, which pretty much shows how many runnable processes or runnable threads are available for a single CPU, right? This kind of shows us to what extent CPU is overload, right? Because when you are having your CPU pegged, let's say at 100%, you may have pretty much nobody in queue, right? Nobody waiting for CPU to become available, or you may have, those 200 of Java threads kind of waiting for CPU became available. Now, another thing which I find very important to look for MySQL is memory, right? And I like to look at the memory both from physical memory standpoint, which is very obviously well understood, as well as a virtual memory standpoint. Why is that important? Well, because when MySQL runs out of memory, what's going to happen? Well, it's going to crash, and then it's going to do kind of crash recovery. That is often not what you want to happen. Right there, if you have run out of a sort of like a, if you have to use the swap, right, especially modern SSDs, right, a little bit of swapping is not that problematic. Especially what you would find often, some of the junk may be, swapped out from a operating system, right, which is not used, right, especially in small VMs. What I like looking at from a swap standpoint is not just not so much specifically like a swap size, right, but I would say their swap activity, right, because if you just have a swap file and no swapping going on, right, then, well, there is no performance loss. Pretty much, right? Like if you can see in this example, right, I have like about, well, half a gigabyte of a swap file usage, right? But we can see pretty much no swap activity going on, right? So that means I'm not overcommitting my memory resources from MySQL, buffer pool standpoint, right, and so on and so forth. And again, I think especially in the smaller VMs, MySQL tends to allocate a lot of extra memory, right, for stuff like performance schema and so on, right, which may not be actively used unless there is significant load. Okay. Now, another thing which is I find always very interesting to work in terms of monitoring would be the disk I/O, right? Why is disk I/O is kind of complicated? Because with CPU usage, it's very easy to see when our CPU is overused, right? Because we know, well, CPU has, let's say, 64 cores, right? It can run 64 threads in parallel efficiently. If we try to get more threads, queuing is going to happen, right? And efficiency is going to lose. But what about storage? Well, the storage those days is a very, very complicated, right? We actually cannot very easily to understand how much concurrency it can handle before queuing starts to happen and latency starts to increase, right? Like even if you think about your local like SSD, right? Even like the one I have on this laptop, right? It actually has, some unknown amount, right, of their units which can execute I/O requests, truly in parallel, right? It's no more like your spinning disks, which was very easy to mentally model, right? So because of that, what I like to look is say, hey, we can be looking at their disk I/O latency, right, and comparing that to historical latency, right? Like in this case, we can see those dots as kind of a current latency, and those graphs as kind of a latency which has been, average over like last few hours. Then you would see, when you oversaturate in storage, then you would see your latency, right, because of the queuing will be substantially higher compared to average, right? And that is, I think, is a very, good telltale sign what you are overloading your storage. Another thing I think important about the storage is what you want to separate reads and writes, because in modern storage they have a completely different I/O path, right? Like in this case, right, and can have a completely different latency. Like you can see again, even on this simple, little box, right, the average read and write latency, right, is different by 3 times, and sometimes it can be more. Okay, well, you guys been quiet. Nobody say that. What the fuck are you talking about, Peter? Which I waited so much. I can tell you, right? And Fred signals me we have another 3 minutes dedicated for questions. Yes.
Firstly, thanks for PMM. I got a question about scaling the PMM server, because I got multiple servers,
Uh-huh.
and can I scale it? I use your local image in Kubernetes or operator.
Mhm.
How to scale PMM server?
Well, so we have some plans, right, to split it out, right, and bunch of things which are used inside PMM can be clustered, right? Both like a click house, Victoria metrics, right? They can be done in a cluster environment. We just don't provide that functionality yet. Like you can see with that kind of single node, we have 500 plus nodes, right? Which people have per node. That's I would say typical scale usage.
Is it possible to extend it to other databases?
Well, it is, but I would say it is not easy, right? So it doesn't have like a very specific. Oh, this would be like a plugin for Oracle. But well, as it's an open source project, everything is possible. It just probably requires more elbows grease, right, than you would want. Yes.
Have to be one metric analyze for monitoring.
Oh well, I think this is kind of like hard question, right? I mean, I would think about that to say, hey, you know what? It's just as with a sick person, right? You can say, hey, what's the metric? Well, maybe you measure, for a fever, right? But that may not catch a lot of diseases too, right? So I wouldn't say that's like there's just one metric. I would say from the outset, right? I think it goes to what I stated about the queries, right? Hey, you know what? Looking at the query performance, right, is very valuable, right? Like even if you want to average it out, saying, hey, maybe 99 percentile query response time, right? Because I would say that will catch a lot of issues, right? I mean, that plan, CPU overload, right? It will impact that stuff.
Thank you, Peter.
Okay, well, thank you.